Okay, back on the topic of the machine learning APIs. Today we're gonna cover up the AWW Vision API, that is the Cloud Vision API from a Kubernetes cluster. So something new in this laboratory. Let's take an overview. The AWW Vision Lab uses Kubernetes and Cloud Vision API to demonstrate how to use the Vision API to classify or label images from Reddit's referent IWW subreddit and display the labeled results in a web app. Let's preview how does this subreddit look like. Okay, it got some wholesome like pets and other cute animals, as you can see. So now we know what we will be working on. Come back to the laboratory. Okay, and we can clearly see that the AWW Vision has three components. A simple Redis instance. Redis is a somewhat like database or other services redundant. Next, a web app that displays the labels and associated images. And third component is a worker that handles scraping credit for images and classifying them using the Vision API. Next, Cloud Pub/Sub is used to coordinate tasks between multiple worker instances. Let's check what does the Cloud Pub/Sub mean. A group. Okay, what is PubSub? Get a comprehensive overview of PubSub from core concepts. Okay, learn more. Now we can see that PubSub is an asynchronous and scalable messaging service that decouples services producing messages from services processing those messages. Pub/Sub allows services to communicate asynchronously with latencies on the order of 100 milliseconds. That's pretty cool. Pub/Sub is used for streaming analytics and data integration pipelines to load and distribute data. Is equally effective as a messaging-oriented middleware for service integration or as a queue to parallelize tasks. Next, Pub/Sub lets you create systems of event producers and consumers called publishers and subscribers. Publishers communicate with subscribers asynchronously by broadcasting events rather than by synchronous remote. Okay, we're right back. Okay, we just comprehended the components. Now, let's come to the objectives. In this lab, we will learn how to perform these tasks. Create a Kubernetes engine cluster, deploy the sample AWW Vision app that uses the Vision API, and next visit your new web app and start its crawler. Great. Okay, can't wait to start this out, seriously. Okay, now I'm pretty convenient that we can skip the setup and requirements as we did that multiple times for now. And let's go to the first task. So it would be create a Kubernetes engine cluster. Okay, great. We will use gcloud, Google's Cloud command line tool to set up Kubernetes engine cluster. You can specify as many nodes as you want, but you need at least one. The cloud platform scope is used to allow access to the PubSub and Vision APIs. Okay, that's great. From now on, let's start the laboratory. Okay, now I can open the Google Cloud Console in the new incognito window. Set it up right there. Okay, now Copy the credentials, student04, yes, that's true. Next, password. Great. Okay, I understand. Okay, agree to the terms of servicing. And now we can start. Great. So use the Cloud Shell. Okay. And we have to run this command to create a cluster in the US Central 1 vSON. Okay. Hide the navigation bar. Press continue. Okay. As we connect to the Cloud Shell terminal, we have to wait a little. Oh, as you can see, we got connected. And now on, let's write this command gcloud config set compute/zone US -central 1 -b. Okay, authorize Cloud Shell. Yes, we do authorize that. Okay, great. Now we have to start up the cluster by running this command. Okay, so let me copy that. gcloud container clusters create AWS level vision, nodes 2, scopes, cloud platform. Okay, copy set. Okay, it took several minutes, but the cluster has finally been created. You can see all here, all the logs we got. Okay, so now I can check the progress to be sure. Yes, the cluster has been created and the task got accepted. Okay, next, run the following command to use containers credentials. Okay, gcloud container clusters get credentials AWS vision. Okay, fetching cluster endpoint and auth data, kubeconfig entry generated for AWS vision. So that's great, the effect we wanted. Now verify that everything is working using the kubectl command line tool. Okay, kubectl cluster -info. And we got control plane, glbcd default backend, kubedns, DNS, and metrics server. Great, everything is running correctly. So we come to the next task of creating a virtual environment. So first off is to create a Pythonical virtual environment that is used to isolate the packages that you install for your application. Oh, I opened something, excuse me. Okay, so sudo apt get install, yes prefix actually, and virtual env. Okay, the virtual environment got installed. Now our task is to build one using this command python 3 -m now double venv and venv and venv. Okay, the environment got built. Now we have to activate that. For this we use the command source vn vin virtual environment vn /bin and /activate. Okay, as you can see here before our student ID, we got this vn in bracket. That means that the virtual environment is correctly running. Now, get the sample. The next task, we have to add sample data to your project by running this command. Okay, gsutil. Now -m cp -r gs comma /spls /gsp 066 /cloud -vision dat. Okay, it's the command to copy some data. Okay, operation got completed, over 80 objects got copied. Okay, great. Now, the next task is to deploy the sample in Cloud Shell. Change to the Python /AWW Vision directory in the cloned Cloud Vision repo. Okay, cd Cloud Vision Python AWW Vision. Okay, our path changed. You can see it right there. And now we have to build this up and make it continuously, and for that we are using the make all command that was prepared for us. Now let's write make all, and as part of the process, Docker images will be built and uploaded to the Google Container Registry, private container registry. In addition, YAML files will be generated from templates filled in with information specific to your project and used to deploy the Redis, the web app and worker Kubernetes resources for the lab. Okay, as you can see, the Docker image here is being built. So we have to wait a little until it gets done. This is okay, some Easter egg how they make. Okay, so back on this topic, the whole app got built. The make call command was run successfully, so we can now get to the next task of the checking the Kubernetes resources on the cluster. So the command for that is kubectl get paths. Okay, we got 3 AWS Vision workers, 1 AWS Vision web app, and also the Redis master like pod. And pod is pretty similar to what the processes are on the operating systems. So okay, next list the deployments by running the command of kubectl get deployments. Now -o and space wide. Okay, so there are 3 there are also 5 deployments, but the AWS Vision worker got stuck. There, as you can see, there are 3 out of 3 of them. Okay, so these are our deployments. Now I'm gonna run this command of getting the external IP address of the web app service, and we can do that by running the following command of kubectl now get svc and now AWS Vision minus web app. Okay, and now we got the cluster IP and the external IP. As you can see, also the type is load balancer. That's a Google Cloud service and pretty convenient. Now you can see we also got some ports set for us, and also we can read from this command the age of our deployment. In that case, it is also already 11 minutes. After running all these commands over the kubectl, we can check the progress of our laboratory. And the task was to deploy the sample. Now let's check that. Okay, we're fine with that. The task got accepted. Now we can move on to the visiting our new web app and starting its crawler. Now, what we have to do? The task is to copy and paste the external API, not API, IP, my bad. So I'm copying it into a new browser to open the web app, then click start the crawler button. Okay. Okay, so I opened a new card in the Chrome. Now we can just press the start the crawler button, and we should and soon we should get all these images like on the example below. Next, click go back, and you should start to see the images from the Reddit subreddit, from this Reddit subreddit classified by the labels provided by the Vision API. You will see some of them is classified multiple times when multiple labels are detected for them. You can reload in a bit in case you brought up the page before the crawler was finished. Okay, so now as I press go back, I should be able to see some of the images. Not in this case. Okay, what went wrong? You can reload in a bit in a case you brought up the page before the crawler was finished. I'm not sure. Okay, try to reload the page. No, nothing appears. What might be the reason behind that? Click start the problem button. Next, click go back and should start to see. I don't see anything. Okay, here's there where the camera lays. There is a view source button. Let me press that. We got moved to the GitHub platform with the Google Cloud Platform courses. Okay. Here is the AWW Vision, the current one we're using. Okay, everything named. Wow. Did you know that all these courses were on GitHub? Hosted. And, like, they're not hosted, but they got the version control here. Okay. Czekaj. Okay, let's check this one more time. No, nothing is appearing right there. Weird. Okay, maybe that's due to the connection issues. I don't know. Okay, so we have to continue. Let's assume that the app is looking like on this picture right there. And now we have a test. Below is a multiple choice question to reinforce your understanding of these lab's concepts. Answer it to the best of your abilities. And what if I open this page on normal browser, not the incognito? Maybe that's the reason why it isn't working as it should. Let's start the crawler. Crawler started, images should start appearing. Go back. No, not really. Okay, there must be something wrong. Okay, come to the lab. Not this. Not this. Yeah, this one. Okay, so some of this allows developers to easily integrate vision detection features within application, including image labeling, face and landmark detection, and much more. That's the Cloud Vision API. That's all for this video. See you next time.